As Malaysians, we all have experienced driving behind a lorry dangerously overloaded with oil palm fruit bunches. Each bunch can weigh up to 50 kilos, and you always worry that one of them might fall out and hit you. It's fascinating. When that lorry reaches an oil palm mill, the fruits will be stripped out, leaving just the empty fruit bunches, EFB. EFB is a problem because there's so much of it. A typical mill can produce up to 15 tons of EFB per hour. What do we do with this waste EFB? So far, nothing great. Boiler fuel, compost, composite board, that's about it. But EFB also presents an opportunity because it could be feedstock for the next generation green bioplastic polymer composite. EFB can be converted into cellulose nanocrystal. Cellulose nanocrystal, CNC, is the fragments of plant cell walls that have been reduced in size down to about 100 nanometers. Turning the tough EFB fibers into nano-sized fragments involves a series of chemical and physical processing steps. The objective of my research is to explore environmentally friendly and sustainable methods towards CNC. After all, a green product must be green all the way through, from the raw material source, at the manufacturing plant, and at the disposal site. So far, I envision a three-step green process. The first step is to use a relatively low toxicity solvent mixture of toluene and ethanol to remove any residual oils and waxes from the EFB. Second, I use a novel material, a mixture of choline chloride and oxalic acid. Both of these compounds are non-toxic, made from renewable sources, and while both are solid powder at room temperature, when mixed together, they are liquid at room temperature. Weird, right? They are eutectic, deep eutectic solvent, DES. The DES mixture will break down the cellulosic material of the EFB, removing the other compounds, lignin and hemicellulose, leaving just the pure, partially hydrolyzed cellulose. The third step is ultrasonication, which is a very energy-efficient method to disintegrate various material. The sound wave works like tiny scissors, separating and cutting the cellulosic fibrils until we get just the cellulose nanocrystals. Remember I mentioned green bioplastic polymer composite. How does CNC fit into this? You see, current bioplastics are not very good honestly in terms of their strength and durability. In order to improve their mechanical properties, additives can be added into the bioplastic like CNC. See, because it is nano-sized crystals, CNC can act like rebars, tying together and reinforcing the structure of the bioplastic. Ladies and gentlemen, my hope is that this is the material of the future.